Okay, a bit of thermal physics. So can you calculate the energy needed for this ice to get to water at room temperature? So what we need to do here is we obviously need to think about energy gets increased because we know over time, so again, if we have temperature, we have time, we know we're initially starting with ice. The ice is going to increase in temperature, it's going to change state, and then becomes water. My water is going to increase in temperature. Now we know that ice changes state, or water ice changes state at 0 degrees Celsius, right? If we assume it's a pure substance. So again, we know when it goes from -25 to 0, what we're doing is we're increasing the kinetic energy. Then when we change state, we know we're changing the potential energy. And then we have our water at 0 degrees Celsius. My water then increases in temperature, and we know that's going to be increasing kinetic energy. Now we know anywhere time it increases the kinetic energy is because it's going to be due to that change in temperature. So the energy equals mc times the change in temperature. So one thing I actually forgot to include here, so hopefully a bit of rage bait, I didn't tell you what the mass of the water was. Let's say the mass is 1 kilogram, just to make our life easy, okay? So the energy then is going to be the mass, which is 1, times the specific heat capacity, because we're starting as ice. I'm going to use my specific heat capacity of ice. And hopefully everyone noticed here the kilojoules. Now they'll try to trick you out with that sometimes. So 2.1 kilojoules is 2.1 times 10 to the power of 3 joules per kilogram per Kelvin, times by the change in temperature. So if the ice starts at -25, we know we have to increase the temperature to 0 in order to change state. So the change in temperature is 25. So what we're going to do now is 1 times 25 times 2.1 times 10 to the power of 3 to give me an energy of 52500 joules. How much energy I need to put in there. Then I know a change in state. We're going to use the equation E equals ml. Right? As a change of state, it's going to use that change state of fusion because we're going from a solid into a liquid. So my solid is going to my liquid, so we're using this number. And again, they try to catch you out, look for the kilojoules. So what I'm doing is my mass is 1 times by 334 times 10 to the power of 3. So that energy is going to be 334,000 joules. Now the last little bit then is now we have our water at 0 degrees Celsius. So I got water at 0 degrees Celsius, and my water needs to increase temperature to 25 degrees Celsius. So what we're going to do is that energy equals my mass of water times my specific heat capacity of water, because we're now water. So my specific heat capacity of water is 4,200 times by that change in temperature. We went from 0 to 25, so the change in temperature is 25. So I do now is 4,200 times by 25, and that energy then is 105,000 joules. So the total energy we have to input to increase its temperature, to increase its kinetic energy, to increase its potential energy as we break those intermolecular forces, and then to increase its kinetic energy again, we just have to add all our numbers together. So we're going to add, we're going to add 52500 plus, 52500 plus 334,000 plus 105,000. To get my total energy, it's going to come out as 491,500 joules. So grand.